Hello everyone, I hope you guys are well. Welcome back to the CCNA training. And in the last session, we discussed about something called as in the last few sessions we have discussed ACLs, in which we discussed standard ACL and extended ACLs. Then we learned about network address translation. And we worked on a practical of PAT, which stands for port address translation. Now we have today something called as port security. So we are going to discuss about something which we can use to configure a secure network on our devices, and we will be learning how we can do that using some technologies like port security. So basically, if we start learning about port security, we can understand this with a topology like this, where we have a switch and a device, then a PCB, then another PC, let's say PCC. And if we talk about MAC address formation, then as of now, there will be no entries in the MAC address table. And when PCA tries to communicate with any other PC, let's say PCB, the switch 1, which is this device switch, will learn about the MAC address of PCA. And similarly, when PCB will reply to the unknown unicast flooding, which will be done by switch in order to know about where PCB and PCC is, at that time, switch will learn about the MAC address of PCB, let's say WB. Then similarly, if any communication happens between PCC and any other PC, during that time, it will learn about PCC using the MAC address CC. So MAC address table looks like something this, and let's say this is the interface 01 and 0/2 and 0/3. So switch creates this table by learning that on 01 I am connected to MAC address AA, then on 02 I am connected to BB, then on 03 CC. Now, whenever there is no entry related to the destination MAC, switch does the unicast flooding, and after that it can learn about the devices which are connected. So now let's assume that you are the administrator and you have to configure a network where you are required to give IPs to 10 users. And let's say you have this switch, then you have a PC here, then similarly one more PC, and just like this, the 10 users are connected to the switch. Now, if we assume the MAC table, it will look like something this, right? 01, 02, and so on till 0/10, and their respective MAC addresses. So let's say AA for the first PC, BB for the second PC, and like this going until something like, let's say, JJ. Now these are the known 10 users which have to be connected using the switch. So now let's assume there is one attacker also. Now, if you configure port security, the moment this attacker connects to any of the port between 0/1 to 0/10, the port will go down. So let's say there is an attacker and this attacker tries to join this network on interface 0/5. What port security does is, so let's say there was 0/5 and the user on 0/5 was EE. Now the moment switch realize that this user is not EE and is someone else, let's say anything like ABCD or any other MAC address, whatever other than EE, if anything connects to that switch on interface 05, that interface will go down and won't be like using that interface, making communication won't be possible. You guys understand how port security works? This is about port security. So there are two different methods how you can like configure the port security on switch. So the very first thing is by entering the MAC address manually. What do you do here is like you go to interface 0/1 and you tell the interface that a device with a MAC address AA will be connected to you, and any device other than AA MAC address shall not be able to communicate with any other device. So this is how manual thing works. And if we talk about the other way, that is something known as the sticky method. So what happens there is we connect the devices. So let's say we connect all the legit devices with the switch, and these three devices have a MAC of AA, double B, and double C. So we tell the switch that whatever devices are connected are all legitimate devices, and you just have to like learn about their MAC addresses. So instead of putting the MAC address manually, you tell the switch that the devices which are connected should only be able to communicate in the network. So do you understand how port security works? Now we will use a packet tracer and we will try to configure port security on a topology with a switch and some end devices. And let's understand what all commands are used to configure port security on a network. So here we have the packet tracer with us, and we will quickly place some switch and a couple of end devices. Now, let's assume all these are the legitimate users and there is one attacker. So this is the device who is the attacker, and we don't want this device to be able to communicate with other devices. Yes, exactly. So if you configure it manually, it will learn about that MAC address only, and any other MAC address being connected to that won't be able to communicate. So we will observe the same in this practical, don't worry. So we have these devices with us, and let's just take these three devices only. Now I'm going to configure the IP address on them. 192.1.1. Then on PC1 we will configure a IP of 192.168.1.2. Then on this PC 192.168.1.3. Similarly, on attacker we will configure IP 192.168.1.4. Now if we go to switch and look at the MAC table, we won't see any entry as of now. You can see the MAC address table is empty since no communication has been initiated from any device. We will send some packets from one PC to another, and after that, the switch should be able to learn about MAC addresses of the devices. Now, if we have a look at the MAC table again, we can see that we have three MAC addresses connected on FA02, 1 and FA03. So we have the MAC address of all the PCs connected to us. Now we will enable the port security on these devices. We go to configuration mode and we will go to interface FA01, which is being connected to PC number 1. Interface FA01. First of all, you have to change the mode of this interface. So we will say switch port mode access. Since by default these ports are in dynamic mode, so we have to change that to access. Then after that, switch port security, then switch port security. After that, you have to tell it about the VLAN which the devices are part of. So we all know they are currently part of default VLAN, which is VLAN 1. Now we have successfully, okay, all right. So we don't have to tell it about VLAN. Instead, you have to tell about how it should be learning MAC address. So we'll say switch port security MAC address. And after that, if you press question mark, you will see you get two options. So h.h.h 48-bit MAC address. So the first part or the first way is by entering the MAC address manually by typing out the MAC address. And then next we have the next option as sticky. So that means configure dynamic secure address as sticky. So the currently connected MAC address will be learned by the switch. So we'll say sticky, press enter, take an exit, and now if we have a look at our show port security, we can see that port security is configured on port number FA0/1. Then after that, it says that maximum secure addresses. So how many maximum addresses a switch can learn on this port is 1. Then after that, you have the count of current addresses. So as of now, how many addresses the switch has learned? That's 0. Then how many times the security has been violated? That's again 0. And what action does it takes if the security violation occurs? So it shut down the port. So that too we can change. Now, if we have a look at the commands again, so the very first command was to change the interface from dynamic mode to access mode. So the first command goes like switch port first you have to get into the interface FA01. Then you go like switch port mode access, then switch port security. And we informed the switch that how he has to learn about the MAC addresses. We said that switch port security MAC address sticky, right? Then now we are going to inform the switch what to do in case of security violation. So we'll go like switch port security violation. Then if you press a question mark, you get 3 options. The very first says protect, then we have restrict, then we have shut down. So in case of protect, if some attacker tries to join the network, so whatever packet will be shared from the attacker to the switch will be dropped at the interface. Make sense? So basically, switch won't accept any data from attacker. In the case of restrict, so it will it again won't accept any data, and with that it will also inform the admin by creating a log. So in the next part, when in the third way, which is shutdown, so at shutdown it won't accept any data, it will inform admin, and with that it will also make the port down. So basically the best way to like put ports into security violation method is shutdown. So we can use shutdown for our way to get out of security violations. So we say switch port security violation shutdown. Now we are done with the configuration of port security, and there's one more thing. Uh, the switch will learn about the MAC address only after the data communication. So once I have shared the packet from PC0 to PC1, only after that we can see that switch has learned about the current address, and the count is still 1 as the learned address is 1 for the maximum addresses, and the action is shut down. Now let's say that this attacker gets connected to the switch on FA0/1, and once these two are connected, we can see that the port is still up, but the moment you try to share some data from attacker's end to any other PC, you will observe that this port goes down and data got failed. You understand? We can see that the port is down and is no longer uh, available for data communication. And also the packet which was shared from the attacker's end to the PC1, also that too got failed. Do you have any questions related to this? Yes, when it comes to getting connected to the switch, that's something related to physical, and like let's say that attacker tries to connect to the switch using an Ethernet on the port FA01. So basically this depends on the exposure of your connectivity as well. So that too is a major part of this. So the port will remain in error disabled state. I was about to come on that. But before that, tell me, is there any doubt with the configuration or understanding of the concept that how port security works? Sure, I will write the commands. Don't worry about that. No confusion. Great. So now we can see that there is a red triangle instead of the green one, which is like which represents that the connectivity is there on the device. So if we have a look at the status of interface FA0/1, it says something like ERR disabled. So this means that the port is in error disabled mode, and now in order to make this port up again, a manual intervention is required. So you have to make some changes now. Even if you connect it back to the legitimate user, which is PC0, that again after that as well, you have to like make some changes in order to make the port up. So we will try doing the same. And now if I connect the PC0 with the switch, I can see that even after pressing the fast forward button, the port remains to the same state. Now, in order to make it up again, you have to go to the interface back, interface FA0/1, and run the command shutdown. First, you have to make it administratively down. So now before this, it was in error disabled mode. Now after running the command shutdown, it will go down administratively. If you see the log, it says that interface FA01 is change the state to administratively down. Now we can make it up again by running the command no shutdown. And if we see at the topology, we can see that the port is up again. Now if you try making communication, it will go successful. Shubham, there are both ways available. Whatever is uh, like comfortable to you, you can use the same. Either you can type the MAC address manually, or you can use the sticky one in order to make switch learn about the currently connected devices. So I hope everyone is clear with the practical. Try this out and let me know once you are done with this. And I'm writing the commands here for you. So the very first command is you have to go to the switch, then on interface FA, let's say 0/1. No, Hassan, you can select the whole range as well. So if you select interface range FA01, 02, and 03, so it will work for all three ports. So interface FA01, then the command will be switch port mode access. First we change the mode, then switch port port security MAC address. Okay, I'll have to check about the hyphens. Then after that, sticky, then switch port security uh, violation shutdown, and that's all. Okay, so you can have a look at the details by running the command show port security in the enable mode. So try this out, take your time, and let me know once you are done with this. Okay, so in order to make it enable, you can try this out. Go to the interface and run the command switch port security and check if you are getting the details after that. Okay, great. So whosoever is getting any error or are not getting the details can run this command in order to make it enable on your devices. So everyone is now done with the practical, and let's now move ahead with the next topic. Let me just delete this all. Now we are going to learn about DHCP snooping. So DHCP snooping is something we can understand from a topology like this. Let's say we have a router here which is connected to a switch, and then this switch have some end devices, PCA, PCB, and PCC. Now we have another router here. Now this is a Kali Linux device. Some attacker is using Kali Linux in order to try getting some information from this network which was there. This was the safe network, but this attacker connected this network on the switch in order to get some information. And what it does here is it creates a DHCP pool for these devices. So let's say PCA, PCB, and PCC have a pool of DHCP here, and this attacker creates a DHCP pool for these devices with himself as a gateway. So let's take the IP of this gateway as 1.1 and 1.254 as the gateway, as the IP of this router. So what it does, it creates a DHCP pool for these devices, so that whenever like these devices try to reach outside the network or tries to connect to the internet or any maybe network which is not in their organization, they go through this router. So that this router can have all the information about data which is being sent to the internet or on any other network. So in such cases, we configure DHCP snooping, and we tell the switch that only this port is the trusted port for offer messages. So we all know that DHCP works with some messages which are discover, offer, request, then acknowledgement. So we tell the switch that you just have to accept the offer messages on this port. So let's say this is port number 0/1. So we tell the switch that 0/1 should be used in order to receive offer message. And if you receive any offer message from here, let's say on port number 0/2, just drop the message and don't forward it ahead to any of the devices. So that's how DHCP snooping works. Make sense? You understand how this works? Yes or no? Perfect. So Pradeep, let me repeat myself for you. So what's happening here is, we all know that when it comes to DHCP, okay, I'm repeating myself, no worries. So when it comes to DHCP, we know that PC sends discover message in order to discover the DHCP server, right? And after that, the router shares the IP address with the offer message. Make sense? Now, the thing is that in our topology, some attacker is there and is trying to make himself as the gateway for these devices by creating a DHCP pool with a gateway as 1.254, which is his own IP address. So there's some attacker who wants all the network to be routed towards him so that he can get as much information as he can. And in order to avoid such cases, we configure DHCP snooping. And after configuring DHCP snooping, you tell the switch that, hey switch, you don't have to accept any offer message from any other port other than FA0/1. So whatsoever is the port number which is being connected to our legitimate DHCP server, we will tell the switch about that, and any other port, let's say FA02 or 3, 4, 5, but whatever. So on that port numbers, the switch won't accept any offer message. So any offer message which contains IP with a gateway, maybe the correct gateway, maybe the legit gateway, or maybe the maybe this attacker's gateway, it won't accept any offer message there. So it will accept offer messages on FA01 only. Exactly, Shubham. You got it right. And I hope everyone is clear about this now. Perfect. So now we will understand how we can configure DHCP snooping on our devices. And let's just take the same topology on our packet tracer as well. So we have our packet tracer here, and we have a router here and a switch, then some end devices. Okay. Then let's assume this router as our attacker. Okay. The network which we are going to configure here is 192.168.1.0, and we will assign 1.1 to this router and 1.254 to this router. We'll go to CLI, say no. Okay. Conf t. Okay, let's rename this as R1. Interface FA0/0, say IP address 192.168.1.1 along with the subnet mask. Now shut down, take an exit, create the DHCP pool, network 192.168.1.0. The default gateway will be 192.168.1.1. Take an exit. Similarly, we will go to this router. Okay, let me just rename this to attacker only. And we'll go to the CLI, say no, enable conf t. It is being connected to switch on FA0/0. So we'll go to interface FA0/0, say IP address 192.168.1.254, which is the last IP of the range. Add the subnet mask, say no, shut down. Take an exit, create a DHCP pool. Okay, IP DHCP pool. Attacker. We are naming the pool as attackers, and for the network 192.168.1.0. Router will be 192.168.1.254. Take an exit. Okay, now let's see from where does the PC get IP address. So okay, so now we have our IP from router number 0. The IP is 192.168.1.2 and the gateway is 1.1. Go to PC6, DHCP. Okay. Now, in case this link goes down or in case the PC tries to get a IP address after being disconnected to this router 0, the attacker will be able to assign them IP address with its own gateway, right? We can even try that out if we go to interface FA00 and shut down. Now, if we try getting IP on PC5 again, we can see it's getting it from 1.254, right? Let's make it up again by running the command no shutdown, and okay, perfect. So now we have our topology. Now we are going to get into the CLI of switch, and we will inform switch that you just have to accept offer messages on your interface FE01. So FE01 is the interface which is being connected to the legitimate DHCP server, and any other interface which is being connected to any other DHCP server, you don't have to accept any offer message on that interfaces. So we'll go to CLI, enable, IP DHCP snooping, and if you press a question mark after that, you have to tell it about the VLAN. So we are going to inform it about the default VLAN. So it will go like VLAN 1, and that's it. Now we'll go to the interface DHCP snooping, and we'll go to interface FA0/1 and run the command IPDHCP snooping. And if you press a question mark after that, you can see we get two options, and we are going to use the trust one. So we are trusting on FA01 as a legitimate user. So we'll say trust, press enter, take an exit, and show IPDHCP bindings. And if you look into this table, you will get some details about the clients which are being connected to the devices. Now, even if this link goes down, these devices won't communicate with the attacker in order to get the IP address. Since, however, when we last time made FA00 down, the PC5 got the IP from attacker, right? We were able to observe that it got the IP with a gateway of 1.254. However, if we try now, if we go to interface FA0/0 and make it down using the command shutdown, these PCs won't get any IP using DHCP. So it says DHCP request failed, and APIPA is being used. So APIPA is used whenever DHCP configurations are not correct, or whenever PC don't find any DHCP server, APIPA is being used. So you see this message. Now, even if you try on PC7 or PC6, you will see the same results, and these PC now won't accept any IP being offered by the attacker, since we have informed the switch that FA01 is the port which you have to trust on. So I hope you guys are able to understand how this works. And okay, sorry Shubham, I'm unable to understand your question. Okay, sure, let me write down the commands for you. So you have to, like, after creating the DHCP pools on both of the routers, you can go to the switch, and in the configuration mode, run the command IPDHCP snooping and IPDHCP snooping VLAN 1. Can go to the interface. Let's say you also consider FE01 as the trusted interface. then you have to go to the run the command ipdhcp snooping. Let me recheck that. Okay, that's the command, and there's no dash between them. These are the commands which you can use to configure the DHCP snooping. And try this out. Take your time. Let me know once you are done with this. Shubham, that's a different thing. Some like some we can say some packets are created manually uh, using things like Kali Linux in order to make some changes in the devices. So that would be something related to uh, that part. So that's not something related to the networking part. That's something related to the attacker's part, right? That's a whole different thing to discuss here. Yes, it will work with that as well, Asim. Okay, so try this out. Take your time. Let me know once you are done with this. Okay, so some some of you are getting some error in getting IP address, right? So there can be two reasons. The commands are here written on the screen, Biswajit. So there can be two reasons. The first reason can be that any PC might have got the IP of 1.1. Maybe because of that, the router was there can be an IP clash, right? When an interface is there with already 192.168.1.1 and another PC with the same IP, that can be the reason. And now if we talk about packet tracer, so that's just a simulation tool, right? um, so you can like face such errors when you work on packet tracer. That's not a really I would say big deal. So that happens sometimes, don't worry. The commands are right, and if you try reconfiguring the network, that will work fine. I hope you have uh, I'm saying this after considering that your DHCP configuration was right. So if there is some error in the DHCP configuration, that can also be a reason of not getting IP using DHCP and APIPA being used. Yes, you have to configure the commands on switch. Biswajit, you have to run these commands on switch. No problem. And guys, whosoever is getting some errors, just try reconfiguring the router or maybe the DHCP pool. It will work fine. And even if you still get error, that can be a problem with packet tracer. Don't worry. The commands for DHCP snooping is absolutely correct as we have witnessed here. Okay, so we have another thing here in the chat. Oh, can we bridge two or more interfaces? Cisco router performance. Yes, Shubham, you can do that using layer 3 Ether channels. You can do that as well. So you can bridge two or more interfaces together. Basically, whenever you try getting the IP using DHCP, PC sends the PC broadcasts the discover messages. There is no such timer for that. Okay, let me just try this out as well. Let's see if I too face the same issue and enable conf t. If I make interface f is 0/0 up again, let's see if the PCs are getting IP or not. As most of you are getting the same error, it can be an issue with packet tracer as well. There are some technologies which are not supported on packet tracer. So no issues. We will check this out. Okay. So as I understand, all the commands are right, and even after the successful configuration of DHCP, so still, if DHCP is not working, so maybe that's something related to issue with the packet tracer and not the commands. So we'll have a look at the running config and let's see if we have our DHCP pools active. So we can see that DHCP pool is there for the network and devices. So still, if there is some issue in getting the IP address, so that's not something we can troubleshoot, right? It seems to be an issue with the packet tracer. Don't worry, guys. Uh, we can leave this here. I hope you guys are able to understand how you can configure DHCP snooping, which was the main objective of doing this practical. And we all know how to configure DHCP pools on devices, right? So that's a different thing. We all can configure DHCP pools on our router in order to make PCs receive the IP address successfully. We have done that a lot many times before this practical, and I hope that's clear to you all. The main objective was to make this DHCP snooping being configured on the switch, which we have successfully done, and I hope that's clear to you all. Okay, great. So that was all for today, and let's meet tomorrow at the same time. I hope you guys enjoyed the session, and thank you for joining. So see you tomorrow, guys. Take care of yourself.